Last time that we were together in our notebook, we were practicing bonds with Lewis dots. You could tell me that there was 2 hydrogen atoms here. You could tell me there was 2 fluorine atoms. We went to know that there is 1 nitrogen and 3 hydrogen atoms, but we don't want to have to draw these pictures every time. Okay, so we are going to use some math and think about how many atoms of each element are in each of these formulas. So we're going to flip the page and take some notes on how to do that. So we're going to title this page Counting Atoms. Okay. Counting Atoms. I'm going to leave a little space here, and then we'll have an example, and we'll label this example. Okay, so what does this tell me? Okay, that's H2O. Okay, we got 2 hydrogens, 1 oxygen. But what does this 3 tell me? That there are 3 of them, right? And consequently, there'll be 6 hydrogens from that. So if we take all the time to go ahead and draw the lone pairs that are on the oxygens, that's kind of a lot of time. But knowing that this 3 tells me that there are 3 waters, later on this will translate into moles of water. But for right now, for our purposes, we can think about it like this. What is this number called? This number is called a coefficient. Coefficient. Okay, the coefficient tells me how many molecules or moles of that molecule. We talked about that number moles a little while ago, but for our purposes, we're going to think about molecules for right now. Okay? So what is this number called? The smaller number. This number is called the subscript. Okay? So the subscript tells us how many atoms of each element. So how many atoms of each element are in one molecule. Okay. Now this one's kind of a simple one, but how many elements are in this molecule? That'll be a question that you have on tests and things. How many elements are in this molecule? Well, we can see there's a capital H, there's a capital O. So we want to kind of think about it as every capital letter is a new element. So we remember some of our chemical symbols have a capital and a lowercase, but we know every capital letter is going to give us a new element to look at there. Alright. So some questions that you might be asked are, how many atoms of hydrogen are in one molecule of water? So show me on your fingers how many atoms of hydrogen are in one molecule of water. It'd be 2, because if I look at the one molecule, I have 2, but I can see that from my subscript as well. Another question that you might be asked is, if I include the coefficient, how many atoms of hydrogen are in this formula. So we would say coefficient times subscript gives me 6. So if I'm asked how many atoms of hydrogen are in this formula, so we could go ahead and label this as the formula. Okay. Then we would take coefficient times subscript. Here's another question that you might be asked. How many atoms are there total? So if I look at this formula and I say how many atoms are there total, I could say 3 times 2 is 6, so I'd have a 6, and 3 times 1 is 3, so that would give me 9 atoms total. So anytime I see total, I know that I'm going to be adding, going to add up all of the atoms that are represented there. Now again, I could go back to my picture and I could count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, but I don't want to draw a picture every time. I want to be able to use the math to figure that out. Give me a thumbs up if you feel like that's pretty easy and you've already seen that before, you know how to do that. No, so okay, that'd be a thumbs down then. Alright, so we'll practice. We'll go through some more of them together. But let me show you one that's just a little bit tougher. It gives you a little sort of a wrench in the works. If I have a formula that looks like this, now we have these parentheses, okay? So think about math. When you have something in parentheses, that's kind of its own entity. It's set aside. Okay. But we also have this subscript on the parentheses. When we have a subscript on the parentheses in math, or when we have a number outside the parentheses in math, what do we do with it? Yeah, we distribute. So we're going to use that same thinking to distribute the subscript on the parentheses across the part of the molecule that is inside the parentheses. So when we go to count these atoms, we're going to think about, first of all, what elements do I have? So I know that Ba is barium. If you don't know that Ba is barium, where are you going to go to find that? Periodic table. So we're going to come back to our periodic table. We're going to say, all right, there's Ba, barium is my element. So just to kind of review that. Why is there what? Well, that is a mystery of the ages. Okay, so we have barium, we have phosphorus, and we have oxygen. Show me on your fingers, how many atoms of barium are there in this molecule? Well, ask yourself, okay, what's the subscript? There's a 3 on the barium. Barium is not inside the parentheses, and there's no coefficient. So we have 3. Phosphorus is a little trickier. We have an invisible 1 on phosphorus. So 1, but phosphorus is inside the parentheses, so we have to distribute the 2. 2 times 1 is 2. And we're going to distribute the 2 to the 4 in oxygen. So 2 times 4 is 8, and we have no coefficient, so our answer is 8. What happens if I put a coefficient out there? Okay, so let's go back and think about if I have a coefficient, that means I have that many of that molecule. So now I have 2 of this molecule. So yeah, we're going to double our numbers here. We're going to say 2 times 3 is 6, 2 times 2 is 4, and 2 times 8 is 16. Yeah. Okay. So these are all with the coefficient. Okay. Alright. Give me a thumbs up if you feel like you can get this. You just maybe need a little practice. Okay, let's do some practice together. We'll go to that practice page that's embedded in the lesson.